On this channel, we provide useful programming information with practical code examples. This time, we cover cookie in TypeScript. We walk through practical patterns for handling cookies safely and reliably in both the browser and the server. Enabling subtitles will make the code descriptions easier to understand. A cookie is a mechanism for storing small strings, name equals value pairs, on the client, created via the setCookie HTTP header or document cookie. You can control their behavior with security attributes, HTTP only, secure, same site, etc. Below is the minimal example to write a cookie in the browser. Create a cookie by appending a string to document cookie. If you want to actually run the code, you need to do it within HTML. In this video, we only verify that no compilation errors occur. This code creates a cookie that expires in 7 days. It's easy to use on the browser side, but since you can't set HTTP only, you should avoid storing sensitive information. The following function is a helper that retrieves the value of the cookie with a specified name from document cookie. Document cookie is returned as a string delimited by a semicolon and a space. Therefore, we split it and look for the desired cookie. This function decodes both the cookie name and value to safely compare and retrieve them. It handles duplicate cookie names and encoded special characters, making it a simple yet robust implementation. Cookies have several important attributes, each controlling security and scope of behavior. The HTTP only attribute prevents the cookie from being accessible from JavaScript, helping to mitigate XSS, cross-site scripting, attacks. Note that you cannot set HTTP only from the browser side. The secure attribute restricts cookies to be sent only over HTTPS, reducing the risk of eavesdropping and tampering. The same site attribute controls whether cookies are sent with cross-site requests and helps prevent CSRF, cross-site request forgery, attacks. The path attribute specifies the scope of request paths for which the cookie is sent, and the domain attribute specifies the domain where the cookie is valid. By setting the expires or max age attribute, you can control the cookie's expiration. HTTP only cannot be set on the client side. Below is an example of adding same site and secure on the client side. However, secure only takes effect on HTTPS pages. Same site equals lax is a safe and common choice. For stronger restrictions, use same site equals strict, but legitimate navigations from external sites may stop working. On the server, you can add HTTP only via the set cookie header, so session management should ideally be done server-side. Below is an example using Node's HTTP module. When you set the HTTP only attribute on the server side, the cookie becomes inaccessible from JavaScript, making it harder for XSS cross-site scripting attacks to steal it. Additionally, by adding the secure attribute so that cookies are always sent over HTTPS, you can prevent eavesdropping and tampering and improve communication security. Below is a simple server-side utility that builds a set cookie header string. This utility forms the basis for creating set cookie on a custom server. Libraries can handle many more edge cases. It's dangerous to store important values directly in cookies. We introduce a method that signs values on the server to detect tampering. Here we use HMACSHA-256. In production, you also need to manage token revocation on the server side. With this method, you can check whether the cookie value has been tampered with. Do not include the signing key in the source code. Manage it through secure means such as environment variables. Sessions that use cookies need CSRF protection. Typical mitigations include: set same site to lax or strict to prevent unnecessary cross-site sending. Use same site equals none, secure, only when cross-origin communication is necessary. Use CSRF tokens, validated by the server, for forms and API requests. Do not store the token in an HTTP-only cookie. Instead, provide it via the response body or meta tags, and have JavaScript read it only when necessary. If the token can be accessed from JavaScript, be sure to also implement XSS protections, CSP, output escaping, etc. Require re-authentication for sensitive actions and at login, and prevent session fixation attacks. Below is a safe client example that sends the CSRF token in a header. This assumes the client has already received the token from the server, e.g., in the response body. If you specify credentials, same origin, only cookies for the same origin are sent. On the server, validate the value of the XCSRF token header and verify that the token matches. If cross-site requests are necessary, configure CORS carefully. To send and receive cookies in cross-origin communication, the client must specify credentials include, and the server must set access control allow credentials true. However, restrict this configuration to trusted origins and do not use access control allow origin asterisk. The combination of CORS and cookies is very delicate from a security perspective. Manage allowed origins strictly with a whitelist and avoid unnecessary cross-site communication. Also, when using same site equals none, secure, enforce HTTPS to prevent man-in-the-middle attacks. In practice, use Express, the cookie library, Express session, and so on. Below is a simple example using Express and cookie parser. In practice, set secure to true and manage the secret via environment variables. By using Cookie Parser S secret feature, you can easily work with signed cookies. However, in real applications, from the perspectives of security and scalability, you should not store data directly in cookies. Instead, use a dedicated session store. Browsers enforce special rules for certain prefixes. The __ secure prefix. If a cookie name starts with __ secure, the secure attribute is required. The __ host prefix. If it starts with __ host, secure is required. The path must be /root and domain must not be set. Using these reduces misconfiguration and improves security. To handle cookies securely, consider the following points. Do not store sensitive information directly in cookies. Prefer a server-side session ID for access tokens. Set session cookies with HTTP only, secure, and same site equals lax or strict. Leverage prefixes like __ host and __ secure. Consider signatures, HMAC, and encryption to prevent tampering and eavesdropping. Enable secure and require HTTPS. Aim for least privilege and short expirations. Use CSRF tokens. Beware of differences in same-site behavior across browsers, especially older ones. Regarding cookies, be mindful of the following common misconceptions. Adding HTTP only removes the impact of XSS. While HTTP only prevents cookies from being accessed by JavaScript, XSS can still be used to issue arbitrary requests. You should also employ CSRF token verification, CSP, content security policy, and input sanitization. Secure is unnecessary for local development. Simulating HTTPS and verifying behavior even in local environments improves test accuracy. At a minimum, HTTPS should be used in staging and production environments. Long expiration periods are convenient. If you set long cookie lifetimes, the period during which they can be abused if stolen increases. You can set shorter expirations and incorporate periodic re-authentication and token rotation. While cookies are easy to use, mishandling them can introduce security vulnerabilities. To manage them properly with TypeScript, it's important to understand attributes like HTTP only, secure, and same site, and enforce secure server-side settings. By not storing sensitive data directly and combining signatures with short expirations, you can achieve safe and reliable session management. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. Thank you for watching until the end. If you enjoyed the content of this channel, please consider subscribing.